Okay, now we're looking at the roller coaster scenario. So this is a little bit harder than the previous question because the previous question we saw that the force of friction was the only force that's causing the circular motion. This is actually non-uniform circular motion because what's happening in the roller coaster is we know that as it falls downwards, what we see in the energy unit, it speeds up, goes faster and faster and faster, and actually slows down when it goes up because there's a change in potential energy. But we can still use the principles of uniform motion that we've learned to solve these problems. So let's look at the top, the position 1. So just like with any forces topic, we need to draw a free body diagram. So see, at 1, we have forces acting on it. So we know there's force of gravity pulling downwards. But if we're on top of there, our normal force, just imagine yourself sitting there, your normal force is up. So what we need to recognize for this question is that since we're traveling a circular path, our net force must be towards the center of the circle. So that means our force of gravity vector must be bigger than our normal force. So we have F net is equal to centripetal force, and this is equal to all the sum of the individual forces that's causing that centripetal force. So in this case, we're going to write down Fg minus our normal force. So our normal force is the weight that we feel. It's our apparent weight. So if we want to experience like what will our normal force be equal to in this scenario, let's rearrange that equation. We have Fn is equal to Fg minus the centripetal force, and Fn is equal to mg minus mv squared over r. So what we see is as we round that corner, we're going to feel like inertia wants to take our body up off the course. So we're going to feel a little bit of weightlessness if we go really fast. That's when you see our force of gravity minus mv squared over r. So the faster we're going, the lighter we will feel. Okay, so we feel lighter. Now we get to the bottom of this path. So again, force of gravity is still downwards, hasn't changed, but if we're traveling in a circular path, that means that our net force must be towards the center. So that means normal force must be bigger at this bottom point. So imagine just a picture yourself, you're going down this path, and then suddenly your chair is pushing upwards to make you up this loop. So we get centripetal force once again, and this time we're going to write down Fn minus force of gravity because Fn is towards our center. We're choosing the positive directions as towards the center of the circle. And we end up with Fn is equal to Fc plus force of gravity. So what weight we feel is mv squared over r. So I'm using capital R just because on this loop I call it capital R, plus mass times gravity. So we can see we're feeling heavier. We feel heavier at the bottom of this loop. Okay, so right now we have two equations. So what happens when we're on the top? Now at the bottom, now we're going to do that loop to loop. We're going to be upside down. So let's scroll down. So what's going to happen here at position 3? We're now upside down. So when we're in this upside down position, our force of gravity is still down, but because we are upside down, our chair, the seat that we're in, is also downwards. So we get Fn. So when we write down our equation, we get centripetal force is equal to Fg plus the normal force. So we rearrange this equation, we get Fn is equal to Fc minus the force of gravity, and Fn is equal to mv squared over r minus mg. So you could feel very heavy at the top, you could feel light. So basically what this allows us to recognize that as our speed gets smaller and smaller and smaller and smaller, this value will approach 0. So if Fn ever equals to 0, it means you're gonna feel that sense of free fall. You're gonna feel like you're gonna start dropping out of your seat. If you ever calculate a value which is negative for normal force, well, you can't have a negative normal force, but what that is implying is you're not traveling fast enough to complete that circle. And if you're not wearing a seatbelt or something, you will fall. You fall to your doom.